Good morning, ladies and gentlemen, and a very warm welcome to our Steligence webinar, where we want to demonstrate that steel is a key enabler for the construction industry to meet the ever more stringent environmental challenges. Indeed, in a world where energy efficiency and resource optimization have become essential, circularity is emerging as a truly vital concept. And today, we enjoy both the pleasure and the privilege of broadcasting our webinar from the premises of UNO, a promising scale-up company that is producing circular steel solutions, such as this truly amazing and wonderful office spot that has been constructed from sustainable steel and reusable walls. And the most fascinating feature of this particular office spot is that it happens to host my panel members for today's roundtable discussion. So let's go in to meet and greet them. What a meeting of the minds we have assembled here today. I am glad to introduce you to Chris van der Voorde, who is the founding father of UNO, and in that respect also our true host for today. As a circular economy ambassador, Chris is also co-founder at the Circular Value Institute, where he is developing metrics to measure societal and shareholder value of circular products. Thanks a lot for your kind hospitality, Chris, and looking forward to our discussions on steel as a key material for circularity to meet those environmental challenges of the construction industry.
Thank you for the introduction and welcome in our office.
Wonderful. I'm equally thrilled that I can welcome Dr. Rana Mahmoud to our panel. As her title suggests, she holds a PhD in architecture engineering from Ghent University, where she explored the potential of a new heating and cooling system to contribute to the clean energy transition of the European non-residential building stock. After obtaining her PhD, she assumed the position of Senior Manager Sustainability in Real Estate at Deloitte, where she provided, amongst others, technical advice on decarbonization. And since a couple of months, she started her own business as a freelancer at Eco Narrate, where she helps the real estate sector transition to sustainable net zero operations. She's also an engaged member and project manager at Yes Europe, the forum for young leaders in energy and sustainability. And today in our panel, I am hopeful that she will be my go-to girl when it comes to life cycle assessment, material circularity analysis, and sustainable construction. A warm welcome, Rana. And to close the circle, I am delighted to introduce to you Professor Olivier Vassart, who is Chief Executive Officer at ArcelorMittal Steligence, which is the business unit that embraces a holistic approach towards construction. At Université Catholique de Louvain, he is professor in steel structures, and he's also a visiting professor at the University of Ulster in Northern Ireland. Since the beginning of 2024, Professor Vassart is also the chairman of Construct Steel at the World Steel Organization. Thanks for joining us today, Olivier, and looking forward to your thoughts and perspectives on circularity and sustainability.
Thank you for the invitation. It's really my pleasure to be here in this wonderful space.
We are looking forward to entertaining an animated discussion in this wonderful office spot indeed. I will need to excuse Professor Pierre Engel, CEO of ArcelorMittal Kirchberg Real Estate. Professor Engel is ArcelorMittal's Chief Project Engineer, and in that capacity, he is responsible for the construction of the company's new headquarters in Luxembourg. I can tell you that he is currently taking care of business in Kirchberg, and he regrets not being in a position to join us here today in Zwevegem, but I'm confident that Olivier Vassart will also be in a very good position to educate us on the new ArcelorMittal headquarters. And in our webinar today, I'd like to explore the merits of steel as the backbone of our circular economy. Steel is versatile in its properties. It is stiff, it is strong, yet it can also be surprisingly slender. It comes at a relatively low carbon footprint, especially when compared to other construction materials. And of course, steel is infinitely recyclable. So during our roundtable here today, I'd like to discuss how we can capitalize on that unique value proposition of steel as a circular material for the construction industry to meet the environmental challenges in an increasingly demanding regulatory framework. And I'd like to kickstart our panel by turning to you, Rana, if I may. We'd like to discuss circular steel solutions here today, and indeed we start hearing a lot about circularity, about sustainability. So to frame our discussions, could you please elaborate on the very concept of circularity and its role in reaching net zero targets?
Thank you, Philippe, for the question. Indeed, so what we want to do now is to transition from a linear business model of taking material, making or creating our buildings, and then having more waste. So, getting rid of it, into a transition towards a model that prioritizes the reuse, the recycle, and refurbish and remanufacturing of the material. This means that we are going to close the loop. So from one side, the waste of a process would become the input of another process. And with regard to how does circularity come in the context of net zero, I would like to take the audience a bit backward, and I want to show here a graph about the whole life carbon. And when we talk about the carbon footprint, it's divided into embodied carbon, but also operational carbon. Operational carbon is what we use inside our buildings, a result of heating and cooling and so on. And what you see here in this graph, and it's maybe shocking for some, that the embodied carbon is the highest at the construction of the building. And then you see some peaks along the life cycle of the building, where it is related to refurbishment, to installation, and also another peak at the end of the lifetime of the building. Going to the next slide. In order to assess the whole life carbon of a building, we use life cycle assessment to actually use some environmental indicators that looks at the whole life cycle of the building, at the first stage, the manufacturing of the material, transportation, putting it at the construction site, constructing, then the usage phase, and then at the end is the life end of the life of the building. And what we want, what actually we mean with circular economy, is going beyond this first lifetime and use the material to a second life, a third life, a fourth life, and so on. And trying to leverage on reusing, repurposing, remanufacturing the material, and design, taking into consideration the disassembly of the building later on. I maybe give a small example with my kids when they play with the Lego. So they like to play with the Lego, and they always look at the instruction and build it together to create a form. And then after that, they remove everything and actually dismantle to create another form, and so on. So I hope by this simplified example, I give also to the audience a clear idea on what's the difference between the linear model and a circular model. And of course, circularity is key in reducing our CO2 emission, because by reusing our material and trying to make it have a longer lifetime, we actually try to reduce the waste, but also we reduce the amount of material needed from the beginning as a row, and therefore it will have a lower impact on your whole life, or the whole or the carbon emission of your building. So indeed, circular plays a big role in our goals towards net zero targets by 2050.
Thanks for setting the scene for our discussions here. Rana, I do have a lot of questions up my sleeve for our panel. I'd like to bring to the attention of our audience that you can also chime in and submit any question or remark that you may have on our Zoom platform. We have a Q&A, we have a question and answers. I'll be keeping an eye out for your questions that come in, and I'll blend them in as I see fit. Olivier, coming to you now. You are the founding father of the Steligence approach, which is an innovative and science-based philosophy designed to support the construction industry in creating efficient, cost-effective and sustainable buildings. Could you perhaps shed a brighter light on what this ArcelorMittal business unit is and does, and how it helps the construction industry in promoting sustainability?
Yeah, the idea of Steligence came, it was not called Steligence at this time, came many years ago when I was working in research and development. So steel industry, as many actors of construction, are working in silos, because we are producing products which are used in construction. And when I started to be in charge of the construction R&D for ArcelorMittal, we deep dived a bit the way construction is organized. And we really reflected on this silos problem. So each building was approached by many different people, many different stakeholders, consultants, designers, providers of equipment. And each of them were doing a wonderful job to optimize their part. But we know all that in many things, the sum of all the optimum is never the optimum. So we try to change this paradigm and approach the construction from another perspective, and not look at the product anymore, but look at the building as a whole, really the building as a final object. And we realize that everything interacts together. So at this time, 10 years ago, everybody thought, yeah, BIM will save the world. No, BIM will save all the problem in construction. Yeah, BIM can save a lot of things, because when you do a BIM model, you pre-build the building. But the problem of sub-optimization remains. It means that you need to approach the building, taking everything into account and looking at the interaction between the parts. And sometimes sub-optimizing a part can optimize the whole building. So we started to approach the building like this. We started to approach R&D in steel like this. And we realized that it can be really efficient. We made case studies where we could significantly decrease the cost of the final building, increase the speed of construction, decrease the global environmental footprint. So we started to work like this at R&D stage. And finally, in 2018, we decided to launch ourselves on the business. And we started to interact with engineering office, architect. And what we realized is that the market was really responsive. Today, we have a lot of contacts, not with building designers anymore, but with building owners. So big real estate company, Microsoft, Google, these type of factors, because they are building owners. They are the one which are benefiting the most of any global optimization which can be done. And also today we speak the same language than them. We speak about square meter, we speak about euro per square meter, we speak about CO2 per square meter, which has become one of the most important driver in the construction. But barely never again we speak about product, because these stakeholders, they don't care about a beam, about a floor, about a facade. They want a building. So that's how now the division is working. We are involved at really, really early stage in the project, and we support all these stakeholders to make the right choices of material. So we don't work only with steel, we work with many material, because I'm convinced that the truth is in the middle. So where we combine the different material together to have intelligent buildings. And this is really successful. And of course, the next step is the service we are offering on the delivery of materials. So we can deliver barely any steel that can be used in a building. That was also a particularity of our company, ArcelorMittal. We are producing anything which is needed in a building. And in the past, we were not really leveraging on this scale, because we were only selling individual product. So in each of the product, we have competitors. But we realized that in Europe, there is no one which has the full product range like we have. And so today we are able to leverage on that and to really support the designer to make the most efficient building.
So you're saying that your very first act to support the construction industry was sheer demolition. It was breaking down silos, thinking in a holistic approach, and becoming agnostic when it comes to products. I've just said, Olivier, that ArcelorMittal is in the process of constructing a new headquarters in Kirchberg in Luxembourg. Now, Jean-Michel Wilmot, the architect who won the design competition, promised that this project would be or become a true, real technical laboratory for the possibilities of steel. So would you be in a position to give us a brief update on this new ArcelorMittal headquarters and how steel is used in all its versatility?
Yeah, the target of the competition we made with the architect was really to highlight the versatility of steel, all the possibility that steel can offer. It means we went really far in the design and in the way the building was drawn by the architect. You know, I'm also teaching at university to young engineers and young architects, and I'm always shocked when a student, when he needs to do a project, come to us with a grid of 8 by 8. They start to draw a grid 8 by 8. And when you ask them why they do that, they are still students, they never built anything, they never were involved in the construction of the building. And they are already convinced that, yeah, but 8 by 8 is the optimum. No, it's not at all the optimum. It's an habit that people have taken. So for this building, we wanted really to change this paradigm. And we went really far because in this building, we have 18-meter span between the external skin and the atrium. And these 18 meters are column and wall free. So it's a totally open space of 18 meters that will allow the tenant, so us, the Luxembourgish state, and some other colleagues of Luxembourg, to arrange the internal of the building as they wish. They will be totally free. They have access to all the services. Everything is flexible everywhere. So this is, let's say, the first big step that we took. It was to be able to remove any wall and any column. So in this building, it's a concept which is not existing. There are no columns, there are no walls. That's the first step. The other thing is that we worked a lot on the natural light, on the thermal comfort of the tenants and the users. So the atrium in the middle of the building will really help to be a thermal damper.
You use transparent steel to promote natural light?
No, we didn't use transparent steel. We use the steel where it's necessary, but it's a glass and steel facade. But we have some plenum in the facade that needs to be put for some fire reason and safety reason. But we really combine all this to optimize this natural light. We also looked at the circularity, as you said. We tried to make the building with the minimum amount of pieces which are different.
Yeah.
So once again, we didn't optimize each penny of each beam everywhere because we wanted the element to be standardized. So often architects, when they think about standardization, they think about a shoebox. I think the building we will do will be far away from a shoebox. The architecture is, for me, magnificent. The shape of the building is really magnificent. And this is done with standard element. So that's the way we approach this, the philosophy of the building.
It's an intriguing picture that you're painting us, Olivier, and I, for one, am looking forward to hosting one of the next Steligence webinars, hopefully in this new ArcelorMittal headquarters. Turning to you maybe now, Chris, and perhaps first in your capacity as the CEO of UNO. You founded UNO as a sustainability evangelist, and your deep motives are even hidden in the very name of the company. Rana just talked about Lego. I have reason to believe that you're a big boy who's still fond of Lego. So allow me to ask you, why did you embark on this journey with UNO? Which concepts are you developing and selling, and how do they, in your view, contribute to a more sustainable future?
Yeah, thank you. So I started out actually as an engineer with a passion for interior walls. So it's not only sustainability, but it's also that passion for just construction and building interior walls. And then at a certain point, when I just had my 2 kids, I realized that every year we throw away a value of 300 billion euros of interior walls. We just build it and throw it away, single use.
We trash it.
Trash it. So 300 billion euros comes in the economy, and then every year it just dumps out. And I find it not very intelligent to throw away $300 billion a year. Then you go into the sustainability part, and you see it's 1% of global CO2 emissions linked to single use of interior walls. And this is where I started my company. I wanted to find a solution for that issue. And I named my company because that is actually Jules and Noor together. So after doing all this venture and so on, I will be able to tell my kids, okay, we made every wall in the world circular, hence we saved 1% of global CO2 emissions. Thus, okay, I, as a dad, I did my responsibility for you guys.
It's your mission statement as a parent.
Mission. Yes, indeed. My kids will ask me, okay, Dad, you knew about climate change. What did you do about it? I will make every wall in the world and on the moon and on Mars circular. That is the ambition. And this is going to give the economy $300 billion back euros back every year. So everybody's going to be happy with that. That's the idea.
Thanks a lot for that very passionate answer, Chris. Rana, we advertise this webinar as a discussion on steel as a key material for circularity. When we talk about circularity and sustainability in the construction industry, are materials the most important factor, or do you see other elements that could also contribute to, say, greener buildings?
This is a good question, Philippe. Indeed, material plays a critical role in actually achieving sustainability or a green building. But it's not just about the material, but as already Olivier explained, it's about the whole interaction with other things, the way you produce your material, the way you design it. For example, I will give an example of a project that I've been working on, but some years ago, where I used lightweight material, lightweight structure, and there we have had a very complex geometrical form that used tons of composites at this time. And what I needed to do as a designer is to go back to the mathematical, I would say, formulas of how to create this geometry. And therefore, I defined different prototypes. By using these prototypes and optimizing the form and optimizing the quantity of the material, we were able to produce different panels. However, it was much more. I mean, we did not use all of the time for the manufacturing. We reduced around 40% of the manufacturing time, if I'm not mistaken. And this is as a result of good engineering, good also optimization for the quantity of the material, and so on. Now also when we discuss about a green building, it's also about the users of the building, how the user interacts in the building. What are the type of technologies that we are using in it? Indeed, material plays a big role, but I see that there are indeed some other aspects in the design. So really it comes from how you design your building. And that's why I always emphasize for architects that I work with as well, that we need to look into the building also as an interactive, I would say, a building. It's not just something static and solid. It also has to be interactive, has to be adaptable, has to be actually, I would say, future-proof for what is coming to be next. So to answer your question, it's not only the material, but a combination of different aspects.
And it's dynamic in nature, and it
Yes.
kind of reflects its purpose.
Yes, of course. Yes, of course.
Chris, you'd like to add?
I would like to. It's good product design is at its heart that delivers flexibility. And I don't know if the video is ready, but I think we also want to demonstrate that with good product design, what you can do is you can, what we do at Juno is we just use steel and we make the installation of interior walls, we make it up to 7 times faster than a classical walling system. then that is due to how the product has been designed. It's telescopic, it's adaptable, and I think the movie is coming up right now. I have no idea. There it is. There you can see on the left the drywall, and on the right the Juno wall. And what you see, it's just built 7 times faster, and at the end of a life, you end up with a building kit that you can reuse instead of a pile of materials that have been thrown away. And
this is by virtue of your patented technology?
Yes, that's product design.
Okay.
And so with product design, we can save on labor, and if you save on labor, you can use more valuable materials inside the wall. You can create just more valuable buildings that are, for instance, have 80% less embodied carbon in the materials, that are fully flexible. And this is the core idea, I believe. If we go to circularity, we need to reinvent some products. We need to completely reinvent products from the base up to reduce the cost of labor in those products and increase the value of the products and make them adaptable, make them flexible.
We're talking embodied carbon here. I'd like to come to you, Olivier, with, I'd say, an obvious but maybe a cunning question on steel as a sustainable construction material. I think it's fair to say that steel is a circular material because it's infinitely recyclable. But would it be correct to also call it a sustainable material? I mean, I think it's a poorly kept secret that producing 1 ton of steel through the blast furnace route comes at the expense of emitting roughly 2 tons of CO2. So would you call steel a circular and a sustainable material?
Yes, so first of all, there is not only one way to do steel. You have cited the blast furnace, which is, let's say, the predominant way today to do, let's call it virgin steel. It means you take iron ore from the ground and you transform it in steel with the blast furnace. But there are also other industrial routes which are existing, and when I say industrial route, it's not prototype.
It's proven.
It's proven, it's there. We have some mills in Europe, like in Hamburg, which work with what we call direct reduction. So I will not enter in technical detail, but in direct reduction, you replace the coal that you use in the blast furnace by gas.
Yeah.
And simply doing that, you divide by 2 the carbon footprint. So you jump from 2 tons, 2.4 tons, to 1 ton, 1.2 tons of CO2 per ton of steel. So they are already today industrial scale capabilities to significantly low down. And then, of course, you have the recycling loop. You said that steel is recyclable, but steel is not only recyclable, steel is recycled, which is a small difference. You have a lot of materials which are recyclable, but where the business model is not working. Yep. It means that even if they are recyclable, they are not recycled in reality because the loop is not there, the economics are not there. Since the 80s, with the creation of the electric arc furnace, any piece of steel which is recovered is remelted and is creating a new steel. So we can say today that in Europe, about 90 to 95% of the steel is recycled at the end of life. Okay, today we are speaking a lot about reusing, circularity. I will come back on that later. And another point, we must not only look at the material per kilo, because this makes absolutely no sense. What we need to look at, it's the property in use. It's what is the quantity of CO2 which is necessary to build 1 square meter. If you have a material that allow you to put just few kilos in a building to build a building, okay, it's not existing today, but barely whatever is CO2 footprint, the CO2 per meter square will be small. So that's the way we are approaching when you speak about holistic. You need to look at everything. And there is not only one steel. There are many different steel grades, which has many different steel properties. And what our team is often doing is that they are helping designers and real estate developers to put less steel in the building. It's a bit schizophrenic from a material producer point of view to tell people you need to use less steel, but it's a reality. There is the possibility to first significantly decrease the amount of steel for the same property. It means for the same column and the same beam, you can have it with less steel.
Yes.
So directly you will decrease the CO2, you will use less material. You can combine with other materials. So the philosophy, the right material at the right place is really the mojo they have, trying finally to get the smallest CO2 per square meter built, or the smallest euro per square meter built, because it's also a big driver from the construction companies to do the building in the budget.
Now, I hear from Chris that product design is important. You are saying you need to look at in-use properties, and the metrics are euro per square meter, CO2 per square meter. If you allow me to challenge you on that, how does that equation factor out for the Kirchberg, ArcelorMittal headquarters?
Yeah, today for the Kirchberg, it's still a bit early. We are still in construction phase, but we have many buildings where we have helped the real estate company, and I will not give the name of a company, but it's one of the largest real estate developer in the world, and we made with them a tower in London. So it was not a small thing; it was a tall building in London, and they have made the final study because they build it. It's not theoretical. So we made some theoretical calculation, but then they made it. And now they are advertising for us, because in real estate fairs and so on, they are presenting this building. And they state that thanks to what we have done together, they have saved 38% of the CO2 emission compared to the UK benchmark. And UK benchmark is already quite low, so 38%. And they saved 8% of the cost. It means that going for circularity, going for low CO2, does not mean that the building will be expensive. Of course, they have used really expensive material. I think one of the most expensive we can sell. But at the end, when you do the final equation, amount of material which is used, type of material which is used, and CO2 in this material, they reach a saving in money. So combination of saving CO2 with saving on the budget of the building. I never saw that in my life. Nope. It's the first time. You know, usually any building which is done, people are exceeding the budget. You are a bit specialized in Belgium for some train station and so on. But usually in building industry, that the budget is a challenge, and people are often overshooting the budget. Here they undershoot the budget of the building.
That goes to show that sustainability does not always imply overshooting the budget. I'm also hearing that your clients become your biggest ambassadors, so that's absolutely wonderful. I'd like to throw in a question from the audience already, also to motivate our participants to keep conveying their messages. There's one that's pertinent, I think, for the discussion at hand, because Olivier, you talked about breaking down silos. Rana, you talked about embodied carbon. There's an obvious concern here, and it relates to, I think, raising awareness. The question reads, do you think that a medium Belgium structural engineering office is actually aware about the embodied carbon of concrete, of steel, or engineered wood?
Well, it's I would say it's a work in progress. Yes, and I'm saying that from experience, because I have already met with architects, designers, and one core mission of Eco Narrate is to really coach and to raise awareness. This is because I believe that by raising awareness, we would actually nudge the audience and try to make them think about what can we do better, or which process, what is there, what are the goals. And there are a lot of questions, for example, coming to me like, okay, we see a lot of clients asking about the EU taxonomy. How can we make a future-proof EU taxonomy building? And then we discuss about their process. Are they taking into consideration the full actually the full carbon footprint? That's what I showed today. For the majority of people, designers, they know about the operational carbon footprint. I mean, the operational carbon. That's now everyone knows about it. Everyone is using technologies, innovative technologies to reduce it. But there is still a low awareness, or it's still, I would say, a process that is ongoing to understand the impact of embodied carbon and what does it imply and how we can calculate it and how can we reduce the overall embodied and actually also operational CO2 of a building. So I think it will all come by raising awareness, attending courses. I think such webinar or other webinars or other coaching sessions helps to nudge or actually, inspire them to dig deeper and have a better knowledge. But it's still a work in progress.
It's a work in progress, but thanks for educating the market on embodied carbon. I'd like to hear your views, Chris, as the founder of the Circular Value Institute as well. At that institute, you have developed a circular value index to assess the feasibility of applying circular business models. So if you don't mind my asking, what is this circular value index and how can it be used to evaluate the viability of a circular business model?
Yeah. So I co-founded also the Circular Value Institute because I believe that the transition to a circular economy is actually, it's going way too slow. We need to speed it up, and this is a lot of to do with the mindset that, sustainability, it's more expensive. Why we just heard the case is sustainability is not more expensive. You just need to make a smartly designed building. A smartly product design leads to lower embodied carbon and lower prices. And then how do you measure that? How do you measure the fact that it is a economical, logical thing to do? And that is actually what the Circular Value Institute brings with its formula. It's a method to put a quantifiable number on the economics of circularity. So it makes the value of circularity measurable. And we look at 3 components only. We look at the residual value of a component, we look at the cost to reuse the component, and we look at the risks. So imagine my favorite, the product I want to replace, a drywall. The residual value of a drywall, it's the only thing you can actually, if you just demolish it like the classical way, is the steel. So you can get out of a square meter of drywall, you can get 8 euro cents. But then somebody needs to go to the building, needs to take the elevator, smash it all down, brings it down, trash 90% and bring the other part to your furnaces so that you can remelt it. And that costs roughly 26 euros a square meter. So you get 8 cents and you pay 26 euros. Nobody does that. That's utterly stupid to do that. You just dump it, you put it in a hole. That is how we do normally construction materials. Now, you talked about Legos. Yeah, do the same thing with Legos. If you look at Legos, that Lego set that is standing there, I can sell that for 800-900 euros. And the cost to sell that Lego set, it's going to be maybe 10 euros or something on an online auction site. So I can get 800 euros for that set. I can even just throw it in a box. I don't need to take care of it. And I get a lot of money, high residual value for almost zero cost of reuse. And then the final part that we also need to take into account, if that Lego set was made out of asbestos, like the things on your roof, then yeah, if there is something risk associated, you need to take that into account. And so this 3 parts, you take the residual value, you divide it by the cost of reuse, it gives a number. If the number is higher than 1, the product is logical to reuse. If the number lower than 1, you don't want to reuse. And then the beautiful part of that is by calculating the number, what we also seen is around 1, you'll see producers like the carpet producers, they have products that have a circular value around 1, or wooden panel producers, they will take it back for free. Then that's a number. Our products, they all start at a circular value around 3, meaning so for $100 of 100 euros of labor cost, you get 300 euros of harvested materials. This is why we buy them back. So we give money to our clients to buy back our own products. So we sell it, and then we buy it back, and then we sell it again. This is totally different business model than the single use. We make more profit the second time than the first time. And if you even go further than that, if you see if you can make 10 times more money by reusing your materials versus the cost of reuse, is it the number if it's 10, then we can apply things like a circular discount, where we actually, we sell you the product, I sell you 100 euros of walls, and then I'll give you 10 euros back if you sell me the right to reuse it, so that you are not the owner. You can own the wall, but at the end of a life, I have the material. I can recuperate those materials, and then I sell them back again for 100. This is a totally different way of doing, but this makes that a circular product becomes 10% to 20% more cost efficient purely to this discount compared to other materials. And this is how we completely reinvent certain industries. And what I see in other industries, if you switch on the light switch of a circular business model with a high circular value, within a decade, everything changes. And the same thing is, for instance, I compare it with rockets, another passion of mine. In the 60s, we go to the moon, we have a single-use rocket, and everybody says, it's not that smart to just build a rocket and burn it all down. Then they put billions and billions and billions in a rocket that you could reuse, the space shuttle. And it could be reused until that an accountant came by and they said, okay, but the cost of reuse, it's crazy high. It's just go to the Russians and buy some space there. And okay, they canceled the complete thing. So, and this is always, if linear economy is going down and in the end it's all China, it's all somewhere else where it's cheaper to produce, not here. So it's a downward street to the end. And then now what happened a few years ago, somebody thought about, let's make rapidly reusable rockets. Now 95% of all kilograms that go to space is circular economy. Within a decade, it's completely switched and nobody can follow anymore. And this is also what excites me so much about circular economy. It is a light switch. If you create a circular valuable product, which we can explain you how to do it, then you have super interesting business models that just wipe out all the single-use products.
It's a light switch, it's a game changer, it is thinking outside of the box or outside of the pot for that matter. I'm hearing a lot of intriguing and fascinating ideas here on circularity, on sustainability. At the very same time, I think I need not to convince you that we have seen a staggering inflation in recent years, that the cost of living has surged to unprecedented levels, and needless to say, I think also the transformation to DRI and to greener steel making will require massive investments. So Rana, what I'm trying to gauge here, when you look at the market, is sustainability a nice to have or a need to have? So are real estate developers, but also citizens by the end of the day, are they willing to pay a premium for circular solutions? I heard from Olivier that often it can even be an addition, well, it can be a reduction or a discount on your budget. So will sustainability become a client or a customer requirement in the foreseeable future?
Well, from my own point of view, it is a must-have.
It's a must-have. Yeah.
It's a must-have. There is no other way to try to hide from it, because we see already from a risk perspective, but also from a value perspective. If we talk about the risk perspective for the real estate sector, you have the climate change risks, and you see we were impacted by floods. It's just like around the corner. And therefore, you have a lot of buildings that were damaged, a lot of money that has to be paid by insurance and so on. But also you see a transitional risk, because now there are a lot of regulations coming, pushing towards becoming or having sustainable real estate at an asset level, but at also the financial sector level. So from everywhere there is the push. So there is no way around to hide from sustainability. I believe the question here is more about how fast are we going to react towards that? Is it going to be now? Is it going to be in the coming 2 years, 3 years, 10 years? Sustainability is about value, social value. It's about also actually marketing yourself as a sustainability leader. So take the opportunity now to become a leader and start now. Because if you start in the coming 10, 20 years, you are at a risk, for example, for an investor, they are at a risk of losing values of their assets. For a developer, they are at a risk also of having an asset that is not responding or to the market needs. So from my perspective, sustainability is a must-have. It brings value, and we see also with circularity, the value increase, and you can gain value along the way. by reducing your waste, by becoming sustainable, by actually becoming or making it, you are aware, you set it in your strategy early enough to be able to compete in the market. So, and I saw it a lot with clients now. Like I have a very nice client at the moment that we are working together, and I see that they are doing the extra mile to be able to reduce their actually carbon footprint in the coming years. And they are not only doing that, but they're also educating their employees to make everything, everyone aligned. And I'm coaching them, I'm helping them. And they want to become the sustainable partner and leader in the market. So I believe it's a must-have.
Sustainability is a must-have. That's a very clear message. We have 15 minutes on our clock, and I'm happy to see that we have a lot of very interesting questions from our audience. I'd like to blend in a couple of those, maybe one for you or a couple for you, Olivier. Some people are intrigued and motivated by the passionate plea from Chris on reusing and recycling materials. So the question would be, or the questions I read here is, are there any systems on demountable beams? Is there a kind of modular Meccano or Lego system that would promote or favor vertical urbanism? And could we use the current building stock as a material library for reuse and redesign?
Yeah, it's a really big topic. So again, yesterday afternoon, I had a meeting with the Luxembourgish government on this. We are working with them on the dismantling of an existing building to rebuild a new one using exactly what you said, using the steel as material stock. So by essence, steel is an assembled material. When I take the European steel construction, we connect steel by bolting. It means we bolt them, so like a Lego, but 2.0 Lego, but it's made by bolting. So it's totally prepared, I want to say, to be dismantled. So the thing we need to find, it's the right equilibrium in the business model. So I will take a step back and take another product than beams. We are also producing sheet piles. So sheet piles are steel elements you put in the ground to maintain earth. So you can use them as a definite wall, but we also use them a lot on job site as a temporary earth retainment. And for this, we have already, since years now, put in place a business of renting them. So we don't sell them anymore, we rent them, we recover them, we repair them, and we rent them again. A bit the same philosophy than Chris is doing for the interior wall. We do that for the sheet pile. Why have we started by that? Because the lead time of a job site is 1 month to 2 years. It means the immobilization of the product is 1 month to 3 years. So for the beams, it's something which is starting. It needs to be pushed by the willingness of the owner. That's what we see now. The biggest driver is the willingness of the future building owner, which is convinced that they want to reuse material. We will need in the next years, I don't know how long it will take, if it will be 5 years, 10 years, that Europe and the builders need to take political decision on the fact that we need to prepare the buildings that we do today to be dismantleable. Because when I look at the regulation today, to build a building that can be 100% demountable is technically easy. It means everything has been developed, everything is ready. The thing is that, unfortunately, it will cost a bit more. And when I say cost, it's a cost in euro, and often a cost in CO2. Because if you want to standardize, you cannot 100% optimize. Because if you 100% optimize for one function, okay, you will be able to redo exactly the same building. But if not, so you need a bit of compromise. And today, with the actual linear economy we have, this is a burden. You are not rewarded if you prepare a building to be dismantleable. But if you want this to appear really large scale, what Chris really wants to do for the interior, you need to have thousands of buildings which are made like this. So you need a framework that allow you, that allow the builder today to a bit leverage on that.
Yeah. Chris, I'm hearing that you're not rewarded for circular products.
No, it's important, like you're already doing a circular business model because it makes financial sense. That's the thing and this is important. If we want to go fast, we need to make happy shareholders. Shareholders don't care about sustainability, they care about, okay, can we make more profit? So we as designers of a building or as a product, we need to design products or buildings that make shareholders happy and that make the society happy. So better and smarter product design. So that's first thing. And then things go fast. But because otherwise you need to enforce it onto people and you need to enforce sustainability on people, which gives a lot of pushback, which is it's a fight. It's not a so in this case, I also want to emphasize if as governments, if they are wanting to put more circular rules on it, they need to think about the financial metrics behind it. It needs to make business sense to reuse it. We may not spend time in making regulations that lead to space shuttles, because then society will use billions and billions of money and just stop it. Yeah, you can reuse it, but it's not smart to do it. We need to assist from the regulatory point of view that we directly build smart, like Legos. It needs to be inside that kind of regulatory framework. And it's looking at the financial metrics. Is the cost of reuse lower than the residual value? It is as simple as that. And it's the easiest metric to do. Just focus on that. That's what I wanted.
And once the business model works out, it will feed of itself.
Yeah, of course. There are shareholders enough in the world. There is money enough to scale it up. That's not the issue.
Sorry, Olivier?
If I can give a real example on business model. In the 70s, a lot of electric arc furnaces were created in Europe. And what happened with that is that the scrap, the old steel, took a commercial value more than before. Yeah. So before we were using it in the converter of the blast furnace, but in limited quantities. And suddenly, the demand from the industry increased. What happened? I remember when I was a young kid, now it has a bit changed, but we had on the street a lot of people which were passing with small truck and asking people, okay, old washing machine, old things. Why? They were not doing that to save the planet at this time. They were doing that because these old washing machine had a commercial value for them. They created a business with that. And today, the recycling of steel is a real business. We have the ecosystem. I don't like the word business from the bad side of it, but there is an ecosystem which is there, where people are gathering any piece of steel of anywhere, because at the end, it has a value. So as soon as, exactly as Chris said, as soon as the business is there, that the loop is there, it will generalize, because that's the way economy is working.
Yeah. And I think it's a very striking example of the circular value index of old washing machines, which is clearly above 1. We have been talking a bit here also about legislation. I do read some, I would say, conflicting signals in our chat. So some talk about regulation as a headache in terms of administration, especially for the small and medium size enterprises. Others think that regulation can also help in modifying, nudging behavior and hence promoting sustainability. So this one's for you, I think, Rana. What are the current regulatory frameworks in Belgium and Europe that could favor circular solutions? And do you see incentives that actually promote sustainability in the current legislation?
Well, I think that the father of all of the legislation, from my perspective, indeed is the Green Deal. The Green Deal is pushing towards achieving certain targets, and in order to achieve these targets, there is, you see, the the CSRD now on the scene. You see the EU taxonomy at the European level. You see also the Energy Performance of Building Directive at the European level, which is going to all be imposed in, I would say, regional or national regulations. For some, it's a black box. It's a lot to do, I know, but I see that it's a drive. In the market now, what I see with clients and the vibes, that it's driving them to reflect on what they are doing now. In the last 10 years, I was working also in the field of sustainability. It's the first time in the last 3 to 4 years that I see companies are interested to understand what are they doing now, what are they going to do in the coming future, how are they going to report, how are they going to become transparent along their value chain, and so on. So I see regulations as a driver. Indeed, it's a black box, but my role is to simplify it and to help them to digest it. And actually what we see from different exercises, that it helped them to prioritize their actions and set it in their strategy, putting some policies. So going really beyond actually ESG reporting and so on for me is a key, because indeed regulation is there, it's just to push, but the value and the opportunity is by benefiting from these regulations now and trying to go beyond it and setting it in your strategy, in your pathway, your roadmap to net zero, and bringing actually this as a kind of an opportunity rather than a kind of a burden. So this is how I see it. I don't know how you, Chris, see it.
We also did like a lot of those assessments because we claim to be a sustainable company, so we want to back it up by science. And if I talk with others, I think all the regulations, it's a hurdle and it's way too much, and make it a bit more simpler or give us a good piece of software that we can just use. That would be nice. But what it also does, it makes it less fluffy, and it emphasizes companies to do the first thing, the big thing first. So instead of doing some small thing, let's recycle a plastic cap of a bottle or those kind of stupid things, companies, they don't want to do a lot of work, so they want to save CO2, maybe 30-40%. They will find the easiest way to do it, and those are often very readily available, easy to implement solutions. And I think that's a good thing, because now, instead of doing something small for marketing, company will do just the easiest but biggest thing they can do to reduce embodied carbon. This is, for instance, why we as a company, we decided to use the X-Corp steel, because it, for a few euro cents a module that we sell, we save 30-40% of embodied carbon on our end product. It is a no-brainer to say, okay, we reduced 40% of embodied carbon, and that's a no-brainer to do in that kind of situation. So we do now the big things first. And I think this is how we go faster if we don't do the small things first, but only focus on the big things first.
But that's why I think, as you said, to set your priority is really important, and this type of yes, exactly.
This helps.
Yeah.
I have a couple of minutes left, so I'd like to wrap up the discussions. Maybe a quick question for you, Olivier, but it's seeking a short answer. Someone took note of the fact that you said sometimes a lower quantity of steel can be better, and that person asks, if I were to assign a structural engineer in a public tender procedure, could you give me a suggestion for selection criteria, such as the lower steel the better, or the...
Yeah, of course, it depends on the usage. So I'm design engineers also, so it depends where on the building. But it's clear that using higher strength steel will help on an average to save steel. So I don't say that you need to use ultra high strength steel everywhere, because in some parts of the building that will not help. So that will be the work of the engineers. That's also why, my students do 5 years of study to try to be able to design a building. But we need to go a bit further than before. You know, usually people were taking S235 steel. They were doing the design and they were sending in it. Fine, it's available everywhere. It's easy. But today we have steel which is far more efficient than that. And when I say efficient, in CO2, in cost, in anything which is available. So, the role of the engineer has grown compared to the past. In the past, they were thinking a bit about kilos of material, but now that's totally wiped out by CO2 because kilos have no value anymore. You need to really look at what makes sense and where to put it.
So fewer steel, but more engineers. I have 1 minute on my clock, and I'd like to grant those 60 seconds to a very generous host for today, to Chris. Chris, you're sitting close to Professor Olivier Vassart, who is Chief Executive Officer at ArcelorMittal Steligence. If you had one, but only 1 minute to convince him to install office spots and recyclable walls on every single floor of the new ArcelorMittal headquarters in Luxembourg, how would you do it?
Well, I think he already took the first good step. It's 80-meter spans, completely open floor plans, but in there you want to have teams that work the most productively, the most efficiently. And the completely open floor plan, yeah, people just hate it. A lot of people hate it. So you need to make spaces that offer acoustics, that offer silence, that offer collaboration zones. And then you'll see that you put teams in that, and those teams, they evolve, they will change. So you will design a floor, and then 6 months later, a year later, you're going to say, oh, I want to change it because my team and my company changed, and I want to have the best for my team. So then you're just going to declick the walls, put them somewhere else, and going to be able to do that. Or if you don't choose for Juno, you're just going to pay a lot of money to throw it all out, and then build some new stuff over and over again. And with Juno in the coming 50 years, you just reuse it over and over again, saving you a lot of money and making very happy, good working teams.
You have certainly convinced me, Chris, and we won't allow Professor Vassart to leave this very office spot before he signs off the purchase order. That wraps up our Steligence webinar, so glad that we could go out with a bang. I'd like to thank my esteemed panel members, Chris van der Voorde, Dr. Rana Mahmoud and Professor Olivier Vassart for sharing their insights and perspectives on steel as the circular material of choice for the construction industry. I also convey a warm thanks to the Steligence technical team who facilitated this webinar, for Anfosteel for kindly spreading the word, and of course to all of you who joined us here today. You came in big numbers today. You also submitted a lot of questions, so we will make this webinar available for replay. We will also go to great lengths in answering any question that is still in the chat, in the Q&A. Thanks for now. Thanks a lot for joining. And for those of you who are joining us tonight for the physical event on circular value in the construction industry, I'm looking forward to meeting you again in Ghent tonight.